1.3 complex numbers. So the first one say to write each number as the product of a real number and I. So basically it gives us a square root with a negative in it, so we have to take out an I, and then if we can break down the square root, we will. So 22, the square root of negative 36. So when I have a negative inside, I'm going to take out an I. In general, what is the square root of 36? So this is going to be 6I. Um, 28, negative square root of negative 80. So I don't necessarily know what the square root of 80 is in general, so I'm going to do a factor tree to break it down. So 80 can break down into 8 and 10. 8 is 2 and 4. 4 is 2 and 2. 10 is 2 and 5. So then I can take out in groups of 2. So I have one set of 2s, two set of 2s. So then I'll have a 5 left inside. I've got a negative under the radical, so an I is coming out. So it's going to be negative, and then 2 times 2, so 4, I square root of 5. Next one's find each product or quotient and simplify the answer. So 30 square root of negative 17 times the square root of negative 17. So there's a couple ways we can think about this. We can go ahead and take the I out of each one, and get I squared root of 17 times I squared root of 17. Or you can go ahead and multiply what's under the radicals together. Okay, so when we're multiplying two radicals, as long as they're the same outside, we can multiply them what's inside. So I think that's the easier way, so that's the way I'm going to do it. So this is going to be the square root of negative 17 times negative 17. So negative times negative is going to be positive. Okay, so then 17 and 17, I can take one of them out, so this is just going to be positive 17. All right, 34. I've got the square root of negative 70 over the square root of negative 7. So I could technically do this one the same way, but I'll do this one by taking the I out first and doing it that method instead. So when we're dividing, we can also combine them. So I could have just a square root of negative 70 over negative 7 and then reduce. Or I can take out the i's. So this would be I square root of 70 over I square root of 7. So then the i's would cancel, and then I would have a square root of 70 over 7, which would reduce to the square root of 10. So either way, you'll get the same thing. Let's see. 40. We've got the square root of negative 12 times the square root of negative 6 over the square root of 8. So I'll do this one taking the i's out again because that's realistically what they want us to do in this section. So I'm going to take out an I from each of the top ones. So that's going to be I square root of 12 times I square root of 6 over the square root of 8. So then I can combine what's in the square roots on top. So I'm going to have I squared, and then the square root of, let's see, 12 times 6 is 72 over the square root of 8. Anybody know what I squared is?
Oh, isn't that -1?
Yep. So that's going to become, the whole thing's going to become negative. So negative, and then the square root of 72 over the square root of 8. So that's basically doing one giant radical. What ends up being 9 underneath, so the square root of 9 is 3, so that's going to be negative 3 is the final. All right, write each number in standard form, a plus bi. So 42, negative 9 minus the square root of negative 18 over 3. And we want our final answer in a plus, and it can be minus bi. So I'm going to try to reduce down that radical as much as possible. I've got a negative inside, so I know an I is coming out. And then 18, that breaks into 3 and 6, and then 3 and 2. So I can take out a set of 3. So I've got negative 9 minus 3, and I had the I that came out, and then the square root of 2 that was left inside, all over 3. Now, a lot of people here go, I can cancel 9 and 3. No, you cannot, okay? Because it's being subtracted on top, I can't just cancel it from the front, okay? But what I can do is on top, I can take out a 3 from both pieces, okay? So I can factor it out. So this will become, and actually, well, I'm just going to take out a 3. It doesn't need to be negative because there's no negative to cancel. So take out a 3 on top. So that leaves you with negative 3 minus I root 2 all over 3. Now, because it's being multiplied on top, that 3 times everything in parentheses all over 3, now I can cancel these 3's and be left with negative 3 minus, and normally I write the I in front just so it's not confusing that it's like under the radical or something, but to officially be in standard form, it's the square root of 2 and then the I. Just make sure the I is clearly shown to be outside. Any questions on those so far? All right, find the sum and difference. So they give us something like 48 where we've got in parentheses 4 minus I and then plus in parentheses 8 plus 5I. And so the terms with i's, we have to treat them like terms. So stuff with i's gets added together, stuff without i's get added together or subtracted, depending on the case. So with this one, I would have 4 plus 8, so that's going to be 12. And then negative I plus 5i, so that's going to be 4i. And it always has to be written in standard form, so that a plus bi. And that's all you have to do for those ones. If we have something like 52, though, where we've got, in parentheses, negative 4 minus I, minus, in parentheses, 2 plus 3i, plus, in parentheses, negative 4 plus 5i. What I like to do when I have a negative out here like this is to go ahead and actually like multiply it through, and then I combine all the like terms after that, because otherwise what you have to do is be like negative 4 minus 2 plus negative 4, and I just feel like that causes a lot of issues, so I like to go ahead and rewrite it. I just think it makes it a little bit easier. So negative 4 minus I, and then I'm going to basically distribute this negative, so minus 2 minus 3i plus, or well, I guess it's going to be minus 4 plus 5i. And then you can just combine like terms then. So stuff without i's, negative 4 minus 2, so that's negative 6, minus 4 is negative 10. And then my I terms, negative I minus 3i is negative 4i, plus 5i is just plus I. And then you would be done with that one. And then 54, probably where we're going to stop today, so you can go ahead and do problems for the first half of the section, and then we'll hold the second half of the section for literally next Monday. Seems so far away. So it's 3 square root of 7 minus, in parentheses, 4 square root of 7 minus I, minus 4i, plus, in parentheses, negative 2 square root of 7 plus 5i. So again, with this negative in front of the parentheses, I would distribute it through and rewrite everything, and then combine like terms, just so that, especially with the radicals in there, that's kind of like another like added thing where people get confused. Remember, when we are adding like terms, they have to have the same radical on them, so it has to be like all the square root of 7s can get added together. So I've got 3 square root of 7 minus 4 square root of 7, and then minus negative I, so that's plus I, minus 4i, and then plus, so that's negative 2 square root of 7, and then plus 5i. And then now I can combine, so 3 square root of 7 minus 4 square root of 7 is just square root of 7, or negative square root of 7, and then minus 2 square root of 7. So that's negative 3 square root of 7. Then I minus 4i is negative 3i, plus 5i is 2i. So negative 3 square root of 7 plus 2i would be my final. I'm going to go ahead and show you one product problem, so one multiplication problem, and then we'll pick up the rest of this section. It's only like 5 or 6 more problems that we'll have to do next Monday to finish this section. But 56, we got negative 2 plus 3i times 4 minus 2i. And so with these, we just FOIL, okay? So we would have, all the things. Negative 2 times 4, so negative 8, negative 2 times negative 2i, so that would be plus 4i. Then 3i times 4, so that would be plus 12i. And then 3i times negative 2i would be negative 6i squared. We said I squared is negative 1, so negative 6i squared, so that's going to become plus 6, that whole thing there. Okay, because of the negative 1 for the I squared. So then negative 8 plus 6, so that's going to be negative 2. And then 4i plus 12i is going to be 16i. So I just wanted to intro that for you. We'll do more of those, obviously, next week. And then we'll also be doing this stuff with finding the quotient. So when you have to multiply by a complex conjugate, we'll do all of that next week as well. All right, so your problems so far in this section are 27, 31, 39, and 53. So if you want to get started on those, I'll be adding 4 more to that next Monday. No, you can just wait and we'll turn it in all together. So if you want to go ahead and do it to knock out those 4 problems, to not have as much to do next week, because usually it takes a little bit longer to go through the complex conjugates problems. So probably won't have as much time in class, and then we'll go from there. Yeah.